Okay, let's play around with some asynchronous code. Firstly, just a little bit of code just to check we understand something called the stack, essentially. Yeah, the current stack. So the current order of things queued up, the order of tasks queued up to be run. So we've got just a tiny bit of code there with 3 functions, and the third one has console.trace inside of it, which traces the call stack at that moment in time. I've just put another one down there, but we don't really need that. But I can maybe leave it there for now. So, what is the order, again, of when these functions are run? And what specifically is going to be printed out to the console on line 9? In other words, what is the call stack at that point in time? If you don't know what the call stack is, too many things open again. Yeah, well, is that just kind of giving the answer? Probably is, right? So maybe I shouldn't show it too much. Is there one on here? Yeah. So, can I pause this? Not really. So in other words, the call stack is our thread, our JavaScript thread. Yeah, the original code gets run there first. Any additional tasks get queued in a separate queue, and then only when the call stack is empty do these tasks get run. So this is like your JavaScript program, and only when all of those commands are finished in your current file, then separate events such as web API events, fetch requests, DOM handlers, promises, all these sorts of things, only then do they get run. So you can just think of the call stack as a container for the currently running JavaScript code. That's all it is, really, yeah? It's the JavaScript thread. JavaScript's a single-threaded language, yeah? You might have heard that term before. Okay, so back to the code snippet. What's the order? Someone give me some guesses or what they think is going to happen.
First is line 12.
First is line 12. Yep, so firstly we declare 3 functions, right? And we store them in memory, but we don't actually run any of the code inside of those functions. So as Simon said, line 12, that's where we begin. Console.trace, so I just said that shows the call stack at that moment in time. Yeah? So it shows what tasks are currently queued up to be run, but which haven't been completed yet. So we start with 12. Then 12 invokes function A. So where do we go next? Anyone? Just shout it out. Say again? 3, yep, absolutely. So 3, what does 3 do? Invokes function B. So surely we go there next, yeah? 6. And then 6 invokes function C, which means line number 9 gets run. Cool, I'm happy with that. What about line number 11? Where does that fit into things?
Number 11, I think it's going to be first.
Yeah.
To be honest, but later will be 12 and...
Yeah, so I'll say 11 we didn't really need, but 11 will get run first because it's on the outer block of code. Let me just make sure this is in a block of code, otherwise we might run into problems. Whereas these are nested, right, inside of a function. These bits are contained inside of a function, so they will get run later on. Yeah, so essentially that would be the order there of our code in white. Now, at this point in time then, point number 9, are there any functions on the call stack, or have most of the functions been completed? Has function A completed yet? So it invokes function B, but does it have to wait for function B to finish before it can finish? Yeah. Yeah, so we've invoked function B, and that started this bit of code, but function A is still open, essentially, right? It won't close and it won't get wiped from the memory until function until function B has completely finished, and then the same thing for function B. That won't close until function C has finished. So only when the console trace has finished and we've exited out of the function C block can we then go back and close function B, and then go back and close function A. Yeah, so you've got 3 functions essentially here stored on the call stack, all in mid-execution. We can see that by just running this bit of code now. I don't know why it's popped me down there, but if I go up, that's my first one. Yeah, that's just a little silly console.trace on line 11. And you can see it's just got this anonymous. So that just means that Google essentially has called a function so that it runs your code. Yeah, so they've called an anonymous function, and that means that all of this code is now getting run. But that's still open. Yeah, otherwise this code wouldn't have any container to run in. Then we get to console.trace. At the top is function C, the last one to be invoked. Yeah, so the stack in JavaScript is a last in, first out stack. Yeah, so the last one that gets called goes on the top of the stack, and that's the first one to be removed. So if I go back to that diagram, oh well, let's just finish it off first. So we've got function C, function B, function A. Yeah, that's the top of our stack down. So it means function C is going to close first. When that's finished, function B will finish executing. Yeah, when function A finishes executing, and so on. So that means if we had some sort of console login here in function A, so this one's going to be the last to be displayed because function B is run. We have to run all of function B, all of function C, only then can we go back and resume the rest of function A. Yeah, it's at the bottom of the stack here. It's the last thing to finish running. I'll just demonstrate that. I'll get rid of the line 11. Yep, so we've got our console.trace first. So that was inside of function C. And then I am the last to be displayed afterwards. We could of course keep expanding on this, but hopefully you get the point. I will show that diagram again now. So that's all we're doing, yeah? We're doing a representation of that. Function A was called, function B was called, function C was called, finish function C, finish function B, finish function A. I need a slower diagram where I've got to speak quicker. So that's all that's happened. Code's getting pushed onto the call stack, ready to be executed, and then once it's run and completed, it gets popped off the call stack. So why is all that important? Why is the call stack important when we're talking about asynchronous JavaScript? Well, this is the code that we can run. If function C contains something that takes a long, long time to run, Well, that means all the rest of the code inside of function A and function B are blocked. Yeah, you might have heard blocking code before. And that's when you can see that some JavaScript's running away in the background, maybe with adverts and stuff. You get this quite a bit on some sites. And maybe part of the site has become unresponsive, or you used to get this anyway, going back sort of 5 or 10 years. You used to get this quite a bit before we had a better way to deal with asynchronous code in JavaScript. Yeah, so, as I said before, the call stack has our function A, our function B, our function C originally, and only when all of those are cleared can the extra Web API task events get pushed onto the call stack to also be executed. So the event queue, sometimes called the MacroTask Queue, now that has to wait until the original code has finished executing before it can run its little bits of code. Promises are often, depends on the browser, but promises are often implemented in a MicroTask queue, so they have even less precedence than these tasks here in the MacroTask queue. So in other words, all of the original code must run, then all the macro tasks that are currently implemented, and only then will the micro tasks be able to run and complete. Okay, so let's have a look at some callbacks and some promises in action. Any questions before we move on? All right. So, I've got a function called do slow stuff, which takes 2 seconds, or at least it's got a timeout inside of it that takes 2 seconds. I've got do quicker stuff, which has a timeout inside of it, which takes 1 second. So in other words, this function should take around about a second to execute, and this function should take around about 2 seconds to execute. And we'll just log in something to the console each time. Yeah, just so we can see what's happened first, how long it took, things like that. How shall we run this first? Let's say we just do that first. Which task will complete first, and how long until both tasks are complete? What's that callback up there? Yeah. Yeah, you're just passing an argument in. At the moment, it's not going to be defined, is it? So I might need to take that out, in fact. But we will make use of a callback later to control the order in which things run.
So is it that it's going to call the do slow stuff, and then that will have to complete, meaning it's going to take 2 seconds, and then when that's complete, the next function will be called, so the whole thing's going to take 3 seconds. As you said before, one has to complete, and then the next one will complete.
The way we set it up, definitely. However, does this obey those rules or not? That's the question. Yeah. So one option would be that the do slow stuff will run first. That will take 2 seconds. And then we'll see the slow task is complete, and then afterwards, after another 1 second, we'll see the quicker task is completed, right? That's one option. And that would happen if do slow stuff blocked do quicker stuff, definitely. However, is that what's happening here?
So is JavaScript by nature, is it synchronous?
Yes, JavaScript by nature is synchronous.
Oh, so then they'll just kind of happen at the same time?
So they will kind of get run at the same time. Yeah, do slow stuff will run, that will set the timeout, and then do quicker stuff will run, and that will set this timeout. So these two happen almost instantaneously, yeah, and then we're just waiting for the logs to actually come through, or waiting for a bit of data from an API to come through, something like that. And this is absolutely fine as long as these two tasks are independent. If the quicker stuff depends on the slow stuff, then we're struggling, right? Because the quicker stuff is going to execute first, and it will fail because it will depend on the data that the slow stuff had. Let's run that. So we expect, what? Just to summarize it, someone? The whole thing will take 2 seconds, yeah? And which one comes first? Nope, not the slow stuff. No, because this one only takes 1 second to run. Yeah, so at the moment, we're going to get this. Sorry, that's from the previous thing. Let's run it again. So we're going to get quicker tasks completed after 1 second, and then the slow task after 2 seconds. Yeah? Because they're synchronous at the moment. They're not asynchronous. We haven't controlled the order of their execution in any way. Timeouts, they are asynchronous. That means that this task can get queued on that MacroTask Queue that we mentioned earlier. So the SetTimeout is here. It's one of these tasks. That enables the quicker task to get scheduled on the call stack and also place a task on the event queue. So our original code will place 2 tasks here, the quicker and the slow task, and then after 1 second, that means that the other task can get executed on the call stack, and the first task after 2 seconds will get executed on the call stack. That's what's happening in the current situation. However, how about we essentially want to, if you're familiar with the syntax, do .then, do quicker stuff, right? So we want to make sure that first the slow stuff completes, and only then do we do the subsequent task. What options have we got available to us to make that happen? How do we make our code asynchronous? Arrow function, well, not an arrow function on its own, right? I could have written these as arrow functions. Yeah, so if you need any hints, there's 2 options at the top, right? Callbacks and promises. So these are ways that we can write asynchronous code in JavaScript. So let's quickly look at callbacks first. So in other words, how do I reconstruct this so that the do quicker stuff runs after the do slow stuff? Do you remember what we had earlier? We had like a callback up here, then we had a callback somewhere else. Was it there? Is it there? Okay, so I'll leave it there for now. And then we need to make sure that we're actually passing in a callback to do slow stuff. So that's probably can be an arrow function. No reason why not. And how about we just make the callback invoke do quicker stuff. So our callback function there is, in fact, could we just do it like that? Could we just send in a function like that? So in other words, do quicker stuff is our callback function that we invoke down here. Will that work?
It's the other way, like instead of quicker stuff, over too slow.
Inside of do quicker stuff, you want to do the callback do slow.
Yeah.
So I still want do slow stuff to be executed first, and only when it's finished do I want do quicker stuff to run. Shall I put first slow? And then second fast. Yeah, so this is the opposite order to what we had before, right? Before, when we didn't control it, the fast task finished first. And then the second task took a while and meant that it ran second. Now I want it the other way around. I want the slow task is complete and then the quicker task has completed. Will that work? I don't think that's going to work either.
Because if you apply the same kind of logic of before, so everything's going to happen instantaneously anyway,
Yep.
then why would it make a difference to put the callback inside the first slow task? It's still not going to wait for 2 seconds, it's just going to run instantly.
I agree with that, yep. So it's going to happen instantly. So do slow stuff, runs, it sets a timeout, then it calls the callback, then the second task goes, sets a timeout, that finishes, and then that finishes. So we're still going to be out of order at this stage. So we're going to have fast one first. Sorry, that's other people's answers from a previous boot camp. So we still have the quicker task completed first, and then the slow task. But I can put the callback inside the timeout. And that will work. Because then we've set the timeout of 2 seconds. After 2 seconds, well, we log it, and then we run the other callback. Yeah? So that's a fairly simple way to do it. However, if we had a third task that depended on it, then we'd have to do the same thing, right? So it gets a bit unreadable. Do other stuff. Yeah, so where does the do other stuff go if we want it to run last? It would have to be passed into the second task, right? There's another callback, and then the same sort of pattern, yeah? So we could do something like that. And then we'd have the first, the second, and the other stuff would finally be the third. But this is getting a bit messy. We could, of course, write them as arrow functions as well. But then what you end up with, if they're a bit longer, is this sort of nested pattern here. So they do quicker stuff, they do other stuff, and that's also a callback. You know, it's just getting a bit messy. And eventually you'd end up with this huge pyramid of nested callbacks if you had a lot of tasks that depended on each other. You see how it's indenting, indenting, indenting? Obviously I haven't sorted out my syntax, but you might have heard of something called callback hell. Oh. What's happened to my internet? Come back. Yes, this one. Ricardo's favourite game, right? Street Fighter. think my internet's been very slow. I hope it's still streaming for the guys. That sort of thing, yeah? We end up with that. And that's not a nice pattern. You see, like, arrow function that calls that, arrow function that calls that. Yes, they're just callbacks, but if you have too many dependent tasks, it gets quite unmanageable. And that was a big problem in large, complicated JavaScript code up until 2015. There were non-standard solutions. So there was a guy that wrote a library and he used promises. Now promises enable us to have a better syntax, so that rather than having this nested way of doing things, let's see if I need to mention anything else. Actually, what do we have right at the start? Yeah, so that's what I was on about. Yeah, just that sort of pattern with the 3 callbacks there. So that's fine, we've covered that. But instead of writing that pattern, using promises enables us to just do .then and then one more task. Yeah, and this time we can pass in our arrow like that, or we could just, of course, invoke the function. Yeah, do quicker stuff. Yeah, it wants to be invoked. No, we do need it as a callback, sorry, or as a function, arrow function. So hopefully you'll agree that chaining on lots of .thens like that is going to be a lot more readable than doing something like that. Oh. Yep, what's going to be better? Just stay on the page, please, Google. Alright, so to have a better syntax and to also have better control under the hood of what's going on, then we could use something like promises. That's obviously going to get a bit more complicated, but yeah. Yeah, I think maybe it can be a bit harder to set up sometimes, but of course once you've written these things once, then you can reuse them again and again, and the understanding of the code for other people is based on this bit here, and that's definitely going to be a bit more readable. Set timeout, let's just fix this. Okay. So I think that's very similar to what we had before with the slow task. Except this time, it's not returning the result directly, it's just returning a promise. How do we create promises? Well, like anything in JavaScript, they're just a new JavaScript object, a new type of object. And we can use the new constructor, so we can have const my promise equals new promise. Yeah, simple as that. And then promises can take 2 arguments. You've got resolve and reject. The resolve is what happens, or what data you pass on if the promise was successful. What we've done here? New promise resolve. Reject. Oh, I didn't put my extra brackets, did I? Because we've got 2 arguments. Sorry, my bad. Oh. Right, so resolve is what happens if we have a successful promise. And the reject should be what happens if we have an error. Yeah, just say error. Okay. So, in our case, we had put the resolve and reject in, set the timeout, and then if the promise was successful, then after 2 seconds, log the slow task is complete. So very similar to our previous example. A bit more complicated to set up, but as well as just running the code, promises enable us to send information onto the next function quite easily. This is the callback one. So we'd have had to send some information in the callback there, yeah, if we'd wanted to pass any extra information on. And then that would be picked up as an argument there, right? So let's say I wanted to pass a message into my callback, and I could have defined the message, and I could say the data from the slow task is here, and then how would I log that instead? So I want to log my message here. Just like that. Yeah, will that work? So we haven't passed an input in there, right? So we've got to make sure we've got the input there. So we could call it message from 1, or message from slow. And then we could have message from slow. So now, hopefully, we're going to get logged the data from the slow task is here. Is here, it's fine, right? That won't work because that's promise syntax. So we said we're going to have the do slow stuff, and after that we're going to have the do quicker stuff. Pass in the callback, pass in the message to the callback after 2 seconds. Yeah, all good. Cool, so we've now got the data from the slow task is here. Yes, we are able to pass on data quite easily. If we've run something in this function, we've done a fetch request, we use Axios, whatever we want to do, and then just pass that on to the next callback function. That is totally possible as well with callbacks. And we can do something very, very similar with promises. Do quicker stuff. So this time we don't have to place a callback inside of the promise, because the promise handles that for us. The control flow is written here, right? Do slow stuff, then do the quicker stuff. So quicker task, yeah, okay, that's fine, right? So based on that, do we think the quicker task or the slower task will complete first? Did you spot any mistakes along the way? No? Should I run it? I heard a mumble, but no? Okay, I'll run it. So all we've got now is the slow task is complete. 1 second's passed, definitely. 2, 3, I can wait as long as I like. There's no second message for some reason. Why is that? I can scroll down, but it's not that bit that's the issue.
What's the message that you're passing in?
I'm not passing in a message yet. Okay, even if I got rid of that, and we'll come back to passing in the message later, I still want to say the quicker task is completed, yeah? I'm still not going to get that. Just got the slow task is complete. That's all I've ever got. So why?
What about the reject?
Yeah, what about the resolve reject thing? Over here we said we call resolve if there's a successful promise. Reject we call if there's an error. So we haven't set up that functionality yet. So in other words, let's put it in a couple of places. So if I put the resolve there, what's going to be the order? What log's going to come first?
Do you have to put all of the SetTimeout stuff inside the resolve function? Or does it not work like that?
No, you just call resolve. Resolve just like ends the promise, and if the promise has been successful, so in other words, if you've just successfully got to the end of the promise, then when you call that, the next thing in the chain will happen.
So doesn't it have to go? No.
So what is the order? Is that one going to come first, or that one going to come first?
What do they call it?
So does that mean do slow stuff is going to print first? The slow task is complete? So resolves the promise. So promise is like an IOU, right? I'm going to send you some more information later on. As soon as resolve gets called, we move on to the next part of the chain. As soon as resolve gets called.
What about the reject?
So reject, yeah, you should always have a resolve and a reject to handle errors in your promises, but for now we'll just ignore it, yeah? There's no what? Yeah. Yeah. So do slow stuff. Is that resolve? Resolves the next thing in the chain. Dot then. So when resolve gets called, this bit runs. As soon as resolve gets called, that bit that's highlighted runs.
So does that work?
No, well it works. I mean it's valid code, but it's in the wrong order. Yeah, the slow task will be completed last, and that's not what we want. Yeah, that doesn't read the way we've set it up here.
Oh,
So now we're going to get the quicker task is completed, then the slow task is completed. Because again, we put the resolve in the wrong place. The same as what we did with the callback. So the resolve needs to go inside of the console.log. Or either before or after. Yeah, because let's say we put it there. And as well as the task being out of order, let's say we wanted to pass on a message to the next part of our function, or greeting, let's just say. And we define the greeting inside of the SetTimeout, yeah? because that's the data that we've just fetched. Greeting equals, let's just be really boring for now. So, well, that's going to be a problem anyway, isn't it? Because that's inside of a set timeout. But yeah, not a good example. But anyway, we don't have the message to pass on. That's going to be the problem here. Yeah. So we've got an uncaught error in the promise. Greeting is not defined. So this is where we could use something like reject. We could say if greeting. Sorry, not if greeting. So let's do the ternary, right? If we've got a greeting, then we can resolve with that greeting passed on. Otherwise, let's reject. Yeah? What happens now? It probably will still say that. Yeah, because it's still an uncaught error. We're rejecting it, but we're not doing anything with that. Greeting is not defined yet. So how do we handle our errors? That's where the catch comes in. Catch is for catch the error. I'm not 100% sure this is going to work the way I've set it up, but the principle is definitely right. So if an error is thrown, if reject is called, we should move on to the catch block. And let's just say error. Something is not defined. Was it greeting is not defined? Something like that. Cool. Let's try once more. There we go. And then we get our error spitted out to the console. And the slow task still completes. Woohoo. But the quicker one does not. Yeah, so that would be how you handle some errors. Of course, we could have created an error object here. Let's just call it no greet error. No greeting error. Const equals. How do we create errors in JavaScript? Not like that. New what? New error. Yeah, exactly. Oh no, where's my error gone? So let's actually not just print something to the console, but let's make it an error. You're trying to click somewhere and it just won't let you. But thank you. Good. So we created a new error. Then if we reject it, let's pass in that error. Now what's going to happen when we run it? Oh, I've still got the console log there. Catch, what do I want to do when it catch? So reject no greeting error. So pass that in. Yeah. Let's just say error. Error. No, that's because of me. No greeting error. Greeting is not defined. That's here, isn't it? That's false here. Okay, I'm not 100% sure what I did wrong. So anyway, we'll simplify it again because I'm probably losing most of you. So we worked out if we want to control the order of the promises, after we've got the data, we can call resolve. Yeah, that's the important thing to remember. And that means we can chain on things like that, which means our task will run afterwards. And we can catch things if we reject the promise, or if we wanted to pass on a message, then we could do it in a very similar fashion. We could resolve it and we pass in the message into our resolve method. So I am the message from task 1. Task 1, slow task. Yeah?
Is
So,
that passing the React or?
yeah, it's sort of like, it's just a function at the end of the day, right? So props are things that you're passing to functions or classes, and here you're just passing a string into another method, and it gets picked up by the next thing we run in the chain, by the next function we run in the chain. So now they should resolve in the correct order. The quicker task first, the slow task should finish first. Once it's finished, it should pass on the message to the quicker task, and the quicker task will then log that message after an additional 1 second. Slow task, then I am the message from the slow task, yeah? 1 second later. Why is it called breadcrumbs.js? It's quite cool, but... So that all together looks something like that. Of course, we didn't have to have this complicated timeout if that is confusing you even more. We could just let it go immediately. You don't have to use timeouts inside of promises. So you can think of the resolve method as like the return for promises. So we return from normal functions, yeah, and we resolve inside of promises to pass on some data further on down the chain. So we could have just written it like that, and likewise this one doesn't have to have the timeout. We could just write it like that. However, now there won't be any delay in the execution, it will be immediate, but we've preserved the order. Yeah, this one will only run after the first promise has resolved. Yeah, so straight away they popped up. Oh. Straight away they popped up. Almost instantaneous, but the order has been preserved the way we want. We wanted the slow task to finish and then get the message. Questions on promises? Or has that just blown your mind too much? It's not an easy topic, right? We're moving on now onto the more intermediate to advanced JavaScript topics. So we'll cover asynchronous stuff a bit more this week, and we'll do database connections as well. And then in the final week, because week 7's all of your presentations, so I should have mentioned that this morning, start having to think about your presentations. Jonathan's down to do one, definitely, right? On the Tuesday next week? Yep. Tuesday? No, not Tuesday. Thursday, sorry. Yeah, I know it began with T. But if anyone else wants to reserve a workshop slot, then please let me know as soon as possible. Yeah, any questions on that? And then the last week will be more advanced JavaScript stuff. The tricky interview question stuff, like call, apply, binds, the keyword this, those sorts of things. No? So did that make any sense at all? You're very quiet. Is it just too much? A little bit. Yeah, so like with most of these topics, you can't just look at them once and expect to understand it. You're going to have to play with the code. You're going to have to look at it from numerous sources probably. And that will gradually start filling in your knowledge of this topic, I hope. Yeah. But fundamentally, we just need to know when it's used. So that's when we want to control the order in which things execute in our application. We have two options: callbacks, promises. Callbacks are just functions, right? So you know how to write those. And promises, we use the new keyword to invoke the promise constructor. It has two arguments: resolve and reject. Resolve is for when we want to pass on data. Reject is for when we want to handle errors. We pass on data by chaining on the then keyword, and we catch errors using the catch keyword or catch method. So that was your 30-second summary of the whole thing that we've just done, and the rest is just playing around with it and getting used to writing your own. Yeah? Okay, I will leave it there. Any questions online?
No, all good, thanks.
Okay, Cam, thanks a lot.